Hi, sixth graders, and welcome to our second lesson of Unit 10, where we will be talking about center and spread. Remember, we are in our statistics unit, and in our first lesson of this unit, we talked about how to ask statistical questions. Today, we're going to be starting a series of lessons where we look at how we classify data using single numbers. We're focusing specifically on center and spread today, but we're going to be looking at a lot of different ways and terminology in which we classify data, so make sure you're paying super close attention. We are going to start by looking at this example here, which says, Mia, a sixth grader at Hartford Middle School, was thinking about joining the middle school track team. She read that Olympic athletes have lower resting heart rates than most people. She wondered about her own heart rate and how it would compare to other students. Mia was interested in investigating the statistical question, what are the heart rates of the students in my sixth grade class? Quick note, we know that's a statistical question because there are going to be multiple answers, and we know it will produce numerical data because the data will be in numbers. Mia collected data on the resting heart rates in beats per minute. That means how many times does your heart beat in 1 minute? Of 22 students in her class and recorded them in the dot plot below. This is a lot to look at, and there are a lot of data points here, which is why it's important that when we're studying statistics, we have different ways that we can describe the data and generalize it with just one data point. And one of the ways we do that is through the center. Now, I circled that center area of my dot plot because that shows around the middle of where my data is. It's not an exact middle, but the typical student has a heart rate of 84 or 85 beats per minute because that lies in the center of my data. That brings us to our first fence post. Center represents the number that is towards the middle of the data and most representative of the data. As we look back here, if I said a typical student has a heart rate of 84 or 85 beats per minute, that would be an accurate statement. If I said a typical student has a heart rate of 78 beats per minute, that wouldn't be accurate because that's not in the middle of the data. So, for example, if on a recent math quiz, there was a scholar that scored as low as a 10% and a scholar that scored as high as a 100%, we would say that's a large spread from 10 to 100. But if every scholar in the class scored between an 80 and a 90, that would be a smaller spread because all of the data points were a lot more concentrated between those two numbers. Now that we've talked about center and spread, which are two ways in which we describe data sets, we're going to stamp our key point. A dot plot can help you to describe data in terms of center and spread. We saw in this example how we could identify both the center and the spread in our dot plot. Now let's put this into action and talk about a few more pieces of data. We're going to look at a new example that says, Karen was interested in learning more about the girls' basketball team at her school. She posed the statistical question, what are the heights of the girls in the basketball team? And asked the 12 girls on the team. Here are the heights in inches of the 12 players. And then you see the list of our data set. I went ahead and created this dot plot for us so that we could focus on analyzing it. So the data set that you see of those 12 players is represented in the dot plot below. Now it's your turn to go into Desmos. You are going to hypothesize which number in your multiple choice do you think represents the center of this data? When I say go, you'll pause the video and go ahead and answer that in Desmos now. Go. If you chose the answer of 62 or 63, you were right on track. That falls around in the middle of our data set because I can see there are several points that are higher than that, and then there were also several points that are lower than that. Next question is, what is the spread? So, taking a look at the dot plot, you're going to go into Desmos and identify what is the spread of this data set. Ready? Go. If you said that the spread was from 58 to 73, you were correct. If you said that it was from 58 to 76, you forgot that our spread, our higher number, ends at our highest data point. The highest height, or the tallest person on this basketball team, is 73 inches tall. Those were pretty straightforward, so now we're going to look at a few other ways in which we classify data. The first is called a gap. A gap is an empty space over an interval in a visual model. So my question for you is, are there any gaps in this data? Your teacher's going to pause the video. You'll vote yes or no in Zoom before we come back together. Ready? Vote. If you said that there were gaps, you were right, and I actually drew circles on our dot plot to show you where those gaps are. Those are any spaces on my dot plot where there are no data points. The next piece of terminology that we're going to learn is a cluster. A cluster is a particular value around which data seems to be gathered. Do you see any clusters in this data? Again, your teacher's going to pause the video and you'll vote yes or no. Ready? Vote. There's actually no clusters in this data, which could have been hard for you to see. So I'm going to show you another example of a data set where there would be clusters. And that's what you see in the top right corner that says students' test scores. As you can see there are two areas where there are large concentrations of data, between 64 and 72, and between 94 and 96. The next term is an outlier. An outlier is a value that is smaller or larger than most of the other values in the set. Taking a look at our data set, do you see any outliers in our data set? Again, pause the video and you'll vote yes or no in Zoom. Vote. If you voted yes, you were correct. This data point to the right at 73 is an outlier. As you can see, it is further away than most other data points and kind of lies on its own. It is larger than most of the other values in the set, which makes it an outlier. Our next term is a peak. A peak is the highest point in a visual model or graph. Where does the peak of this graph lie? If you think you know the answer, raise a hand in Zoom and your teacher will call in one scholar to share before I reveal it here. If you identified the peak at 64, you were correct. That is the highest point in our visual model, and that is the most common height of girls on the basketball team. That means our last term here is symmetrical. A data set is symmetrical when the shape of the data is the same on either side of the peak. In other words, if we folded our dot plot along the line of the peak, we would get a mirror image on the left and the right. So, is this data set symmetrical? One more time, into Zoom, vote yes or no. Ready? Vote. Hopefully you voted no. Our data set is not symmetrical because as we can see on the left and the right of 64, we have different shapes in our data. I'm going to show you an example of a data set that would be symmetrical in the top right corner here. As you can see, the peak is at 2, and the data on the left and the right of the peak is identical. Therefore, that data set is symmetrical. We just went through a ton of new vocabulary words that are all summarized on this slide. This will also be in your Desmos link so that you can refer back to it during your practice today. So no need to copy this down or memorize it all now. As you are working on today's work, you're going to be looking at dot plots and data sets and finding the center and the spread and a lot of other of the terminology that we just spoke. So you can get them jumbled in your head. That's why this resource will be there for you on Desmos. As you are working on your classwork today, remember to annotate for meaning, so identify what the question's asking you to do, and then make sure you identify what the question's asking for. Center, spread, gaps, outliers, clusters, peaks, and if the dot plot is symmetrical. There was a lot of new information in class today, so I know you guys are going to do super well on your work today, and I'm excited. Our next 2 lessons are going to be diving even deeper into other ways in which we classify data, so I will see you then.